All right. I think we will get started and let folks continue coming in with a little food. Good afternoon, everybody. Thank you so much for coming. Welcome to Kroon Hall at the Yale School of the Environment. I'm Jen Marlin. I'm the Executive Director of the new-ish Yale Center for Geospatial Solutions as of about a year ago. And I'm very excited to have you here today because this is a really unique conversation, a talk and a conversation after. And it's fairly rare and powerful to have scientists coming together who build reconstructions of climate from little bubbles trapped in ice, along with historians who study papyrus texts from many thousands of years ago, together with a modern hydrologist who works with farming communities today, and bringing all these different disciplines and perspectives together. So all of the talk and then the panel afterwards is really in service not just of advancing the scientific research, but also in supporting the urgent need to understand how societies succeed or fail when their rivers fail them. So the YCGS, or the Yale Center for Geospatial Solutions, we're new on campus, and we're designed to catalyze geospatial research and remove barriers to accessing Earth observation data and analyzing spatial data, and using maps in particular to help promote cross-disciplinary conversations and break down those traditional academic silos. So this event is really a perfect fit for the new center's mission, and we're really happy to be working with the water learning community at YSC, and also the Macmillan Center. And I actually don't have the full name of the center here. I will get it and thank you properly after. And so this evening is going to unfold in three parts. First, Professor Mark Macklin is going to provide a keynote on how rivers worldwide are responding to contemporary environmental pressures. And then Selda Medeniques is going to, she bridges ancient history and climate science. She's going to moderate the panel discussion with three remarkable scholars that she will introduce. And then we will open it up for your questions and conversation at the very end. And so I would like to start by introducing Professor Mark Macklin. He is emeritus at the University of Lincoln, England, and he is a globally renowned expert on rivers and their response to climate change. Published many dozens of papers on this topic, extensively studied how human activities and climate change are transforming the world's rivers, the very lifelines that have sustained civilizations for millennia and that billions of people still depend on today. So with that, I will turn it over to you, Professor Macklin. Welcome.
Thank you, Jennifer. Good afternoon, ladies and gentlemen. Oh, I'm on speaker. Good afternoon, ladies and gentlemen. Just a couple of thanks, and then I'll put my notes away. First of all, Jennifer and Joe for inviting me. Seems a while since, I think it was April 2018 that I was here last. And especially to Deborah and to Magali for helping me, getting me here and looking after me in my transit. Okay. This is going to be a lecture you'll see in 4 parts. And I've been working on the impact of mining systems globally for the last 45 years. It's a $3.5 trillion industry, which has probably got, I think, roughly equivalent to the GDP of UK for what that's worth. And what I want to try and do is go through a series of work that we've been doing over the last few decades to try and understand what the legacy impacts are of base metal and precious metal mining. As you'll see as we go through the lecture, particularly at the end, this industry will fuel, inverted commas, the green transition. And you'll notice deliberately that I put the green transition in those little quotes. And there are significant issues in terms of the mining sector that they're going to have to address. Coming clean, I've worked with the mining sector, the Rio Tinto, Imperial Minerals, all over the world. So I've been both poacher and gamekeeper. I've been a very significant critic in terms of what they've been doing, but as I'm now retired, I can say exactly within reason what I want. But it is, I'm not an eco or green fascist, so to speak, but we are going to need these in terms of whatever transition we actually move to. Thank you, Steve, for setting me up with this, which I'm sure I'll cock up at some stage, but let's go. I want to start with, I am a fluviogeomorphologist, is a river scientist. I work on rivers. Tomorrow we're going to be talking about Egypt and the Nile. Well, I've worked for about 35 years, actually in Sudan. And I want to start off just explaining what the legacy impacts of metal mining are. Unless you're a nerd on these things, most of it's going to be relatively new, but there are some basic processes, some basic understanding that we need really to deal with, particularly the way that rivers process, disperse, and remobilize contaminants. I'll then talk relatively briefly about the impacts of climate change, which have been manifest probably more than 25 years ago, particularly in Europe and many other parts of the world, in terms of this remobilization of waste. I'll then talk about some work that we've been doing in the last 2 or 3 years or so, a mapping and modeling study, which was published in 23 in Science. And then I'll talk very briefly in terms of what the next steps are in terms of green transition. One of the things that you'll take away is that a lot of this work has been mediated by the media. And I like working with the media, but you have to do it very carefully. You must never, inverted commas, bullshit. You must always answer questions straight, but actually, if they are used in a nice way, carefully, the very last slide is a new podcast that Laura Hughes, very eminent journalist of the Financial Times, which I'll share with you at the end. But anyway, let's start this journey. If we go back to the 1970s, I started my PhD in 1980. There was a series of scientists, including myself, but also my mentor, who's now in his mid-80s, John Lewin, realized that contaminants, particularly sediment contaminants in river systems, behaved the same as natural sediment within river systems. And what became evident in terms of work that we did and others was that in terms of river systems, and rivers are simple things like me, in terms of contaminant dispersal, there are a number of processes. This is this snazzy new pointer, which is going to drive me around the twist, but we'll get there in the end. So there are the factors of dilution and hydraulic salting. This is actually the Pilcomayo in South America, which I've worked for many years. And the simple takeaway message here is that sediment contaminants decrease downstream as a consequence of dilution and hydraulic salting. What I mean by hydraulic salting is that things like galena and sphalerite and gold have got a high specific gravity, they're heavy. But also, in terms of mining waste, the natural sediment load of the river dilutes that signal as well. The second component on the right-hand side is that, and this is not from a South American river, this is from a river in northern England, actually drains down to near York. And what these are lead concentrations. I'll come back to this on several occasions. Note the log scale. 10,000 ppm is 1% by weight lead. Remember that figure, because we're going to come back to it. And in this particular environment, The mining headwaters are located here. You can see from the tributaries which bring in the mine waste. But you notice that the rate of attenuation is not especially quick. And the reason for that is you have these contaminated floodplains which were polluted by historical mining, which add a secondary source of contamination. So, dilution, hydraulic salting, the importance of secondary sources of contamination. A lot of which I'm going to talk about tonight is related to these legacy mines, which in some cases go back several hundred years. The other critical factor as well is the way that rivers process that sediment in terms of the way they move it across floodplains. And again, from a simple perspective, this is a small river in Wales. Dragged up in Peckham in South London, but I've actually spent most of my life living in Wales. I actually row with a Welsh-speaking rowing team, but that's another story perhaps for later. But in terms of this particular slide, the takeaway message flow is from top left to bottom right, and the stippled area shows the area of floodplain which has been reworked in the last 150 years or so, which was coincident with mining operations in this catchment. And you'll notice that the larger circles, which have got concentrations above background, are located within that particular zone. So again, we can use river histories, patterns of remobilization as a guide in terms of sediment movement. So the takeaway message from this is that, and I'm not going to talk about water. Water's important, but in terms of and we've done a lot of work on acid mine drainage, but I'm going to talk about the role of sediment, because again, something which is not understood or perhaps appreciated is that greater than 90% of the contaminant load is in a sediment-associated form. And that is fundamental, because it means if that stuff is reworked and stored in the floodplain, it becomes a major secondary source of contamination. The second takeaway point is that if you can actually understand the way that rivers move sediment around a landscape over time, then you can model sediment contamination. And it's as straightforward or as difficult as that. Why does this matter? And I should have come clean over this. I've got an O-level in chemistry, probably meaningless to most of you, an A-level in biology, and I've been doing this for 45 years, and I've sort of become an expert by default. And actually, I started using contaminant metals as stratigraphic markers, looking at Roman mining in the Mendips when I was doing my PhD. So, yeah, if you keep doing these things long enough, you become the, don't laugh, Joe, you could do okay. Why does it matter? They are a major threat in terms of ecosystem and human health. And there's three reasons which probably stand out. The first of these, and this is why I got interested in them in terms of stratigraphic markers, if they've got remarkably long residence times in the environment, hundreds, tens of thousands of years. Lead, for example, is, I've slightly overstated this, not that it's a neurotoxin, which it is, but it is the original forever chemical. It doesn't disappear, certainly over our time scales. And also as well, these contaminants, I've used these, if there's a geochemist in the audience, I'll put this in. The technical term for heavy metals is potentially toxic elements, but don't worry about that unless you're a die-hard geochemist. And the key thing is that in terms of the contaminant sources, we've got legacy mines in northern England. Tailings dams, I'll explain what tailings dams are in a second, in Romania, where we've worked over many years. This is a typical day. I live about 7 miles from this mine. Cwmystwyth, Aberystwyth, where I live. Aber means mouth of. Ystwyth is windy river. So it's the mouth of the windy river. And this is one of the oldest metal mines in the world. And I'll show you a slide in a second. Actually goes back to the Bronze Age. That's what it looks like in a typical Mid Wales day. But on a sunny day, from the top of the hill looking upstream, it was the discovery of a early Bronze Age, actually a Beaker Age artifact, the oldest gold artifact in Wales. This little sundial brooch showed here. And this was a mine which was active in the Bronze Age, extracting copper. Not a gold mine as such. The major gold mining belts are actually further north. But it just shows how important metallurgy, not important, how essential metallurgy has been in terms of, inverted commas, civilization and the development of societies. If we then sort of scale up a bit, as you get older and more decrepit, you get these sort of honorary professorships, and you saw at the very beginning all these labels of various universities. I'm affiliated and honorary around the world. But for my sins, I have worked for more than 20 years in New Zealand and Australia, particularly looking at the Victorian gold rush. And this is a nice old map published in 1907. It shows the major gold-bearing areas of the world. Obviously got the American Southwest, Alaska, Western Australia. But the next few slides I want to show you are in the Victorian goldfields, which are just over here north of Melbourne. This is what they looked like in the 1850s, and basically a moonscape. This is, by I suppose, comparison, similar style of artisanal extraction from Madagascar, shown here at the bottom. It was quite extraordinary, the amount of waste which was moved. It was quite extraordinary, the amount of contamination, particularly use of mercury, and also the legacy arsenic problems in these areas. And again, just to show you how long-lived these are, there is the Bendigo sludge pond, north of Ballarat, north of Melbourne. That's what it looks like in the end of the 19th century, one of these very large tailings ponds. This is sludge, as they call it. And this is what it looks like at the present day. And you can see the pre-mining landscape here in Rutherford, well-known Australian geomorphologist, putting on his hand where the sludge begins. And this is a picture taken in 1909. And this is a picture taken many, many years later. This is the 22nd generation dog Bob, exactly the same picture that survived. Now I'm being cheeky, ironic. But anyway, that is the same location. And you can see what it was like the turn of the 20th century. The volumes that were involved were absolutely incredible. And obviously there are similar stories in terms of California, hydraulic mining there. But this is especially problematic because it's got very high arsenic concentrations. Tailings dam failures. I've spent the last 30 years basically going around the world, starting initially in Porco in Bolivia in 96, then going to Asnarkaya in 98, then I went to Bar Mari. Where do we go next? Mount Poli, and we just started work actually in Chile. For those of you who don't know what a tailings dam is, it's basically where mine waste is stored. One of the innovations which took place at the end of the 19th century is the waste, rather than being discharged directly into the nearest watercourse, was put in a big dam or pond like this, which seems like a great idea until they fail. And part of my research group and colleagues is looking at the remediation of these, and this is the work that I've done mostly with the mining companies of actually trying to sort out the problem when it occurs. Probably the most infamous one is the Asnarkaya failure in 1998, which had a massive impact into the Doñana wetland, and it's really only just recovered. And probably you've seen in the press the Brazilian failure in 2015. So that's the legacy. That's the issue in terms of historical mining. I flagged up the issue that nowadays we store waste in these very large tailings ponds, and there are issues related to that. And I'll come back to that towards the end. Second topic I want to touch on is the role of climate change. And I think, as Jennifer said, my main area of research is looking at the impact of climate change on river systems, both in the short and long term. And back in 2000, he's only just recently died. This is John, probably meaningless. This is the Deputy Prime Minister, John Prescott, Hull docker, infamous in terms of punching someone on the nose who threw an egg at him. I met him in a pub in Newcastle many years ago, but an extraordinary character. And in 2000, in October 2000, we had what were called the Millennium Floods. And John had issues, let's say, but he was prescient in terms of describing these Millennium Floods as a wake-up call in terms of climate change. And actually in terms of the UK, many parts of Europe, if you look at actually the flood records, that is when the major uptick occurs both in frequency and magnitude. And tomorrow when we talk about the longer term, I'll come back to that. So we had these extraordinary floods. We got significant funding from the equivalent of NSF, NERC in the UK, and a now retired professor, same age as John Lewin, mid-age, a guy called Des Wallin. And you can Google Des Wallin, he's one of the most cited fluvial-geomorphologists on the planet. Me and him had this grant, and we were going to look into the geomorphologic impact of this extraordinary flood. But basically nothing happened in this event, geomorphologically. It occurred over a period of about a week, and we, in desperation, we thought, I won't say exactly what we thought, but we were going to have to do something in terms of not giving the money back. So, never give the money back. And so what we decided to do was an exercise in sediment fingerprinting, provenancing. And we thought, okay, we can use these contaminant metals as an indicator of where the sediments have come from, and this might save us in terms of this particular project. And we were in for a shock. I've shown this diagram earlier on, and I'm going to come back to it now. These are metal concentrations in overbank sediment deposited on agricultural land during that event. Again, look at the log scale. 10,000 ppm is 1% by weight lead. You'll notice in blue, these were the flood sediments, and some of the sediment concentrations were in excess of 25,000 ppm lead. And what you notice, as I pointed out in the first couple of slides, is although there is a slow attenuation, because of historic contamination of the floodplains, this secondary mobilization actually reduces the attenuation rate. Also, what's shown there on the sort of black line in the middle is an old guideline, which was deemed acceptable back in 2000 in terms of remediation of contaminated land of 1,000 ppm lead. In terms of what we're dealing with these days, I think in terms of the EPA in the US, it's probably come down to 300. In much of Europe, it's 250. So these are quite extraordinary concentrations. We weren't completely surprised by this. We wrote it up in a nice way. We used our geomorphological understanding, produced a series of hazard maps for this part of the swell system. Shown in red is areas which are highly contaminated, pink affected by floods in the mining period, and uncontaminated. And we wrote this up. It was actually covered on the BBC News on September the 9th, 2001. And obviously in September the 9th, 2001, something happened. and it disappeared off the news. We were then called down by the UK government, and I gave a presentation to the UK vet. And he said, "Oh, Professor Macklin," he said, "you've got your decimal point in the wrong place." And I said, "Don't think I have." And he said, "Oh, this must be a consequence of atmospheric contamination, because the nearest mines are 60 kilometres away." I said, "No, this is a result of remobilization of sediment in these extreme events." We wrote our report. It was actually funded by government departments, and they literally buried it. And if you listen to the podcast, which I'll come to in the end, you'll answer many other things. There's a sting in the tail in terms of the regulators with that. So headline figures there. I mean, ridiculous amounts, 150,000 tons of lead stored just in this relatively small catchment, okay? Right. Where was I? I was in Leeds at that stage. So I then moved back to Aberystwyth, where I live now. My house is just there. This is Aberystwyth on the coast, university town, about 20,000 people. And in 2012, we had them. And as a consequence of this, and there is again an irony here, the College Farm, Aberystwyth, is very well known in terms of its plant breeding station and its cattle breeding program as well. And on the day that this, I shouldn't smile, I was a former professor there and set up the research school. But the day that this flood happened, the university was just getting an award for its organic produce. These are Welsh Blacks, college herd, in terms of meat quality within their canteens. And I'll come back to the significance of that in a second. Exceptional events, again, the sort of concentrations, these are flood sediments taken down the series of rivers in mid-Wales. There's a scale there to give you some indication of the area we're dealing with. In some places, particularly in terms of this little river here, the Clarick, shown in flood, concentrations in excess of 30,000 ppm, 3% by weight lead. This is the College Farm. Concentrations of 7,000 ppm. Anyway, as I said, I do lots of media work, and I was actually advising the Welsh Government at the stage, came back on the train, BBC got me, and said, "Oh, what do you think about this, Professor Macklin?" And I said, in terms of the flood event, it's significant, but my main concern was the contamination legacy. I then had a phone call that evening from and I won't say who the person was, the then Welsh Environment Minister, to say, and there was a series of expletives, "Mark, what are you saying?" I said, "Well, the big problem we're going to have is the contamination." Anyway, this was in June. October, I get a phone call from the College Farm, and Will Hairsign, a guy who ran the farm, said, "Mark, we've got a problem. 12 of our Welsh Black cattle are dead." And I said, "Oh," well, he said, and again, string of expletives, "You were right." And I said, "Well, hold on. The flood occurred in June. This is October." What had happened was that they had been fed silage. The grass had been cut after the flood. The contaminants had been rolled up within, these are like jam roly-polies, so to speak. And then the animals have been fed this contaminated material. To this day, I am astounded. These are large beasts, they're large animals, that these concentrations of lead did kill them. And there was very detailed autopsy in terms of their kidneys, in terms of various offal and so on. These are concentrations of lead within the silage, and these are blood lead levels within the cattle. Again, a log scale, and in terms of the highest concentrations, the unrestricted concentration in terms of lead within animal blood is 0.25 micromoles. The highest concentrations were 35. So quite extraordinary in terms of what happened. Right. Once again, it was picked up by the media. We made the front page of the Independent. But once again, we were accused of scaremongering. We were told that, again, this was a one-off. It wasn't unusual. But the irony was that in terms of, this is what, end of the 2000s, early 2010s, I was working all over the world, mining companies, other governments, using the exact methodology which I'll show in a second in terms of contamination mapping. So our work was being used by many governments and authorities overseas, but not in the UK. Okay. How am I doing for time, by the way? We're good? Halfway. Oh, crumbs. Right. This was a lockdown project. Myself, and I'll thank him at the end, Chris Thomas. We've known each other for many years. He was Deputy Vice Chancellor at Aberystwyth. I persuaded him to move to Lincoln, where we set up the Lincoln Centre for Planetary Health and the new department. And we worked for many years on malaria problems, particularly the hydrological control malaria. But anyway, it's me and Chris that have done this. And we both live in Aberystwyth. And we thought we've got to do something other than going stir crazy, being locked up in our bedrooms or on our farms in Mid Wales. So, with the help of a team of thousands, that's the paper, don't look at that. What we did, and I had two absolutely outstanding postdocs who helped me with this, is we decided that for our sins that we would compile what is still, to my knowledge, the world's largest mine database. So shown in blue are the historic mines, the legacy mines. There's close to 160,000 of these. These are all georeferenced in terms of the commodities they're produced. They're all designated, and shown at the bottom are the active mine sites, about 23,000 of them. I think this is the only bit of animation, Steve, that happens, and I'm probably won't work. Oh, it does. As you see, I'm a sort of traditional slides person, and one of my postdocs gave me this. Anyway, that's sort of, that's enough of that. We also compiled, again, the largest database of tailings ponds. So basically these large repositories of waste, the blue triangles sort of merge into one, so to speak. But you can see the locations there. But more importantly, shown in red are the 257, actually that's 259, tailings dam failures which have occurred in the last 50 or 60 years or so. What we did, and I can send you the 60 pages of SI that went with the paper if you're really interested in this, but you'll notice the dilution control. We basically looked at river systems all over the world, different climates, different catchment size, different concentrations, but basically it broke down to a simple distance decay model. What we did is that we identified distance downstream and we used Dutch trigger levels. I love my Dutch colleagues, wonderful pragmatic people. 530 ppm lead was used as our indicator. This was my clever postdocs. I think very similar to some of the modeling we might be talking about tomorrow. So using hydrobasins, basically georeferencing, putting all of the mining sites on. So again, this is Northern England. This is part of Bulgaria where we work. Then actually using a recently published high-resolution digital elevation model to actually map the extent to which the contaminants are moving downstream. Also then looking at the floodplains which were contaminated. And I'm only going to show this for a few seconds. Extensive 750 ground truths in terms of testing that model to show that it was reasonable. So in essence, what we have produced is a process-based model. It's ground truthed, it's global. And so what we could do for the first time is actually make an estimate for the number of people which were likely to be impacted by tailings dam failures. So globally, something like 300,000 people which lie downstream of some of these major failures. When you look at the press, when you look at the media, these tailings dams are the sort of the poster childs of the failure industry. But when you actually compare it to the number of people that are living on floodplains which are contaminated by legacy mining, historical mining, and also those which are living on floodplains affected by present-day mining, those figures are dwarfed entirely. So something close to 11.5 million people, we estimate, live on floodplains contaminated by historical mining, and something like 12 million people are living on floodplains likely to be affected by contemporary mining activity. So, key takeaway points from that is significant number of people, 23 million people we estimate. I'm going to show you towards the end, and it is getting towards the end, some more granular data we've just produced for the UK. In terms of worldwide, 480,000 kilometre of river channels affected, and the only two notes that I've got is I was working out last night to give you some sort of context. That's 120 times the length of the Mississippi in terms of scale. In terms of 164,000 kilometres of floodplains, that is 1,312 times the area of Boston. So it's incredibly precise and clearly very accurate as well. But nevertheless, you get some indication of the scale of these things. Takeaway point is that it's tailings dam failures get the news, but actually it's people living in legacy mine affected systems and present day mining, which is problematic. There is a significant problem in terms of underreporting. This is not a complete database. About artisanal mining towards the end. And as I say, we do have this mapping tool. This time, it was picked up. So, but I happened to be on holiday in Greece at the time, so I couldn't do any of this, but it was widely reported. And as a result of this, a remarkable investigative reporter, a lady called Laura Hughes from the FT, was tipped off by our local MP that a PhD student, a lady called Andrea Snova from Nottingham, had been doing some testing of eggs and wildlife. And Wales, mid Wales, is always ground zero for these things. I don't know why, but well, I do know why. It's heavily contaminated. And as a consequence of this, this was picked up by many of the politicians. Steve Crabb was the Welsh minister at the time. It then became a special committee in terms of the House of Parliament. And if you're really interested, you can watch me take apart the regulators in the House of Commons, because basically they're not bad people, but actually in terms of the way that they deal with these things, they just concentrate on water. The idea that this is sediment associated, and they've known this for years, I've been publishing it for years, they know me very well, and the group and people, but they just focus on water. Water is great because if you stop putting contaminants within it, it dilutes. Sediments don't. And the main focus has been remediating the mines themselves, but it's the floodplains and channels, 10, 50, 100 kilometers downstream, where the main problem lies. So it's taken a hell of a long while for the penny to drop. As a result of this, there's a whole plethora of programs which have come out. You won't get one of the top left, it's on BBC iPlayer, but you'll get the others. That's another lovely picture. That's a New Scientist. Great drone footage if you're interested in terms of Cymiswyth. And again, just to sort of bring this back to the politics, immediately before the last election, and I don't think this is the reason the Conservatives lost, but hopefully it helped. No, I didn't say that. Hopefully I'm being recorded. It may have had no impact at all. What we did is we identified all the constituencies in the UK. There are 6,000 lead mines in the UK. Okay, Britain was one of the reasons the Romans went to Britain was to go for the lead mines as well as the tin in Cornwall. It was an important area. So what we did, because me and Chris were rather naughty, is we listed the number of mines in each of these particular catchments. And it happened to be that the then Prime Minister, Rishi Sunak's Richmond constituency, was the most affected. But anyway, that's just a bit of political gossip. Again, to give you some indication, we've remodeled this. We're using a much higher resolution digital elevation model. We've actually got much better population data. I'll show you some of the land stuff in the next. So this is the sort of next generation. In terms of the lengths of rivers affected, over 4,000 kilometres shown here. And what we're starting to do for the first time is actually look at the land cover in these contaminated floodplains. And what's interesting is that there are a number of areas which seem to be important in this respect. Intriguingly, there's a high proportion of broad-leaved woodlands. These are in riparian areas. What's happened in the last 20 or 30 or 40 years in many parts of the UK has been significant rewilding, revegetation of our floodplains, and it's broadland areas which are important. Significant areas in improved grassland, freshwater areas, and as you expect in urban and suburban areas. So something in the order of 56,000 hectares. Again, I think my last sort of factoid on this, I still play football twice a week, so this is football. And that is 79,000 football pitches, soccer pitches to probably you guys, in terms of the scale of contamination. And the order of 35,000 people living on those. And we were rather lucky. We've got very good Facebook data. We can actually get this down to individual properties, which is good and bad news. Okay, getting towards the end. I'm not going to read that, but obviously, in terms of the transition from fossil fuels, precious and base metals are going to play an essential role. But the only point you probably need to look at this particular stage is that just in terms of copper, and you probably know something like 10 times more copper in an EV car than a normal car, so to speak, incredibly hungry in terms of metals. There's going to be estimated in terms of the copper usage, there's going to be 2.5 times the entire amount of waste produced between 1900 and 2020. So I'm showing you these tailings dams. This is going to be an extraction on steroids. And there are consequences of that, both in terms of the damage this is going to do to the environment, and also in terms of the impact this will have both on water resources indirectly and directly in terms of both contamination and water use. For those of you who are interested, we've just done a review paper in Nature on this. We have just started some work on a major tailings dam spill in Chile, but that's another story. Okay, last take-home points, and I've got a couple of slides after this just to end things. The question that I'm always asked is, what do you do about this? Okay, which is a very reasonable question. Fortunately or unfortunately, in terms of contaminated floodplains, there is no practical means to remediate them. There's just too many of them. There's just too much waste. You can manage them, you can identify the contaminants are, and then give very careful guidelines in terms of how they're used. For example, you wouldn't allow your cattle to be fed silage after a major flood, for example. But being serious, there is a way through that. Land use controls the entry of these contaminants into the food system. There is a big push in the UK, in Europe, and probably in the US as well. I've seen Australia and New Zealand, are folks growing their own. I live on a hill. We've got a small holding. My wife is a brilliant gardener. We've got raised beds. Doesn't flood. But actually, in terms of a lot of these contaminated floodplains, cheap land, people buy up properties, they don't know the history of contamination. And that is a very serious problem. That's how the eggs were picked up, because basically the chickens were grazing, foraging on these contaminated floodplains. And you have to listen to the podcast in terms of the take-home messages from that. We believe that we know that our process-based modeling can allow us to map these and provide a risk assessment guideline. Intriguingly, certainly the UK and actually some of my European colleagues, particularly those in Spain and parts of Romania, natural rewilding may be just leaving the floodplains alone. Maybe the best way in some instances to do that. We're just extending our work in terms of looking at artisanal mining. That's another lecture. And we're currently doing some work in Amazonia. And climate change, increasing flood frequency and flood magnitude, the rate of remobilization is really the key challenge, which we need to understand. These are the folks that I need to thank. Paul Brewer, Karen Hudson-Edwards, Amog, and John Lewin. John Lewin was my mentor, not my PhD supervisor, and obviously Chris Thomas. This is blatant self-publicity. We have set up a collective called Water and Planetary Health Analytics. And if folks want to join us, subsidize us, so I can enjoy my retirement of being serious, there is an opportunity to do these things, and you can look at the website. And last but not least, Laura Hughes, with immaculate timing, released the first of a series of 3 podcasts yesterday, and I do encourage you to listen to it. It's pretty daunting listening. And although I tend to be slightly cheeky in terms of talking about these things, when you actually listen to the personal stories in terms of what lead does to people, and this is not in terms of the Global South. These are people that are living in the UK. So on that chirpy note, I'll stop. Thanks for your attention.
Thank you so much, Professor Macklin. That was really insightful and daunting is a good word. Disturbing might be another good word. But really important insights because we need to be clear-eyed about the transition that we're facing, and your work and your science is helping us confront the issues that we need to. So, and these kinds of challenges are why we're bringing scholars from very different fields together here for what we're going to have now is this conversation. And so I would like to introduce Dr. Selga Mednieks, a research fellow at Trinity College Dublin and a key collaborator in our interdisciplinary work led by Joe Manning here. Selga is both a classicist studying the ancient Near Eastern and Mediterranean worlds and a researcher working on this Nile River project to connect scientific evidence of climate disturbances with social responses in ancient Egypt and Mesopotamia, all sort of focusing on rivers. And so Selga's work exemplifies what we're trying to achieve here, bringing this historical scholarship together with scientific data to understand society's response or successes and failures under environmental stress. So I'm going to turn it over to you, Selga. Thank you. Actually, well, sorry, one more minute. You can come up. I just wanted to also make sure that I did thank the Planetary Solutions and 3 Cairns Climate Impact Innovation Fund, and I neglected to properly thank the Agrarian Studies Program at the Macmillan Center for International and Area Studies, along with the YSE Water Learning Community. So a lot of groups were working together to put this event on, so thank you to those who helped make this happen. Over to you, Selga.
Thank you, Jen, for that introduction. And thank you, Mark, for that insightful and informative and, yes, disturbing lecture. I'd like to open, before I ask the other panelists to the stage, I'd really like to open with a question for you, if I may.
Sure.
Would you mind?
Yeah, absolutely. Yeah, you can.
As you said, we are reliant on raw materials like copper and lithium and rare earth elements to achieve our goal of transitioning from fossil fuels. And it seems to me that that will mean substantially more mining rather than less. And I wonder what it is that we could do proactively to manage this transition.
It's an absolutely fundamental question.
We seem to be responding a lot. We talk about remediation and so on. Is there anything to do?
I think in terms of mining practice, and I'll put my sort of mining consultant sort of hat on, so to speak, there can never, ever be a completely watertight, so to speak, tailings dam. And that is the major issue, to make sure that the structures are as safe as they possibly can be. That would be relatively straightforward if there wasn't problems of climate change. It would be relatively straightforward if a lot of the mineralized areas in the world weren't in earthquake zones. So I think the short answer to your question is, in terms of the design of these structures, it needs to be as well engineered as possible. And unfortunately, in terms of a lot of the failures that I showed on those slides, and just by way of example, the Asana KR failure in 1998, it's actually a British company that designed the structure. It was built on an aquitard, so basically a water-resistant layer, but there were fracture lines within it. And as a consequence of the water pressure, big storm, it failed. So I think in terms of practice, we need to design these things as carefully as we can. And I've probably seen more of these structures than most. And it's actually quite terrifying. I've just come back from Chile. Quite terrifying at how poorly designed and poorly located that they are. We're going to have to be far more efficient in terms of processing and extracting the metals. It's been suggested to me that we could actually mine contaminated floodplains. And that's an interesting conundrum, because I don't know whether any of you have visited the Yorkshire Dales or Northern Pennines. These are areas of outstanding natural beauty. They happen to be some of the most contaminated floodplains anywhere in the world, but I don't think people would appreciate their floodplains being mined. So it's very difficult to answer your question, but to encourage the mining industry, the regulators, to do these things as carefully as possible. Just one last thought on that. The big unknowns are the impacts of small-scale artisanal mining, and in places particularly like the Amazon, in places like sub-Saharan Africa. Those are not regulated, or they're very poorly regulated at all. Those mines are heavily connected to the river systems. Folks that, we've done a lot of work in Tanzania, where they use mercury to extract the gold. And actually it's the local people that are doing the processing which are problematic. So not a straightforward answer, but I think in terms of each new mine, very, very careful assessment in terms of what the long-term risks are. And particularly if you're dealing with things like lead, copper is less problematic because in terms, unless you've got it in very high concentrations, it doesn't necessarily kill people. It's not particularly good for some vegetation. Does that answer your question? Probably not.
It does, no, it does. So perhaps exploration then, there's in that phase of development of a new mine that you might mention.
Also as well, there is opportunities, particularly in terms of reworking tailings. So basically, if you go to Victoria, Melbourne, if you go to particularly Eastern Europe, go to Romania and Bulgaria, there are huge numbers of these old tailings ponds, and there is very high concentrations of extractable metals within them. But even doing that is not straightforward because that actually creates, unless you're dealing with a sealed extraction process. So yeah, there's a risk associated with all these things. And we just have to make a value judgment on a case-by-case basis. But we need to protect livelihoods, we need to protect people, and we need to protect ecosystems.
And have there been many studies on the effects on animals and ecosystems in the areas that you've worked
lots.
in?
And it's these contaminants are bioaccumulatory. Unfortunately, there's not much testing, so you don't really know that it's getting in you. And I think that's the reason I lost my hair. No, I'm joking. But no, being serious, that is an issue. In the UK, and let's just stick on that because I can be critical, there's hardly any testing at all. There's a new commission which we will give evidence to, and they're trying to introduce testing at the farm gate, particularly in terms of things like eggs. In the UK, there's not even a limit for lead in eggs. We have no blood testing in the UK. I know you do in the US. So it's, you're going to have to listen to Laura's podcast, I'm afraid.
Yeah, it seems there should be some more stringent regulation of.
It is. It affects people's IQ. I mean, it's a poison. I think one of my take-home messages is not to repeat the failures of the past. And I think we can do that, but we're going to have to engineer these things in a much more thoughtful. I mean, I never use the word sustainable anymore. I don't really believe. I think we've gone past sustainability, but in a more safe way.
Thank you.
Pleasure.
Would you mind
Sit.
taking a
Yeah,
seat?
I would.
And
Yeah,
I would like to invite our first panelist, Dr. Vinay Nangia, to the stage. He's a social hydrologist, that is an engineer who is dedicated to finding socially driven solutions to water management problems, particularly in the Middle East and North Africa. And I'd like to ask you, Vinay, about the parallels that you draw between the challenges posed by mining, described by Mark, and those faced by the agricultural sector.
I really enjoyed your lecture, so thank you so much.
Pleasure.
A nice question. I was trying to draw parallels and try to see how you see similar patterns emerging in the field of agriculture as well. So I work in the field of agriculture water management in developing countries. And before I took up this job, I used to work in Canada for Agriculture Canada. And one of the things I was working on in Ontario was the beef that is sold in the supermarkets was contaminated with substances that were flowing in the waterways of Canada. And the top things that they found in the beef was caffeine, painkillers, birth control pills, antidepressants. Those were the things that are found in the meat that we are consuming because our waterways have gotten contaminated. Maybe because of failing septic tanks or other means, but that's what the cattle is drinking and is ending up in our bodies. The other thing, I was at the UN climate change conference last year in Baku, and one of the interesting statements I heard was water is a very good record keeper. It doesn't forget. You cannot create water, you cannot destroy water. All you can do is use it or abuse it. But once you contaminate it, it takes a long while to remove the contaminants. And it's so true, whether it's erosion, whether it's arsenic in the groundwater, everything that we have polluted this water, it takes a long while for that water to return to its original state. And coming from a part of the world where water, land is associated with food security, the conversation that we try to have with the farmers about this green transition happening in the field of agriculture, solar powered drip irrigation systems, solar powered pumps, desalination, all kinds of stuff that's happening. A farmer doesn't care for environment. He's a businessman. He cares for his top line and his bottom line. At the end of the day, embracing green transition means more profit for him, de-risking his agriculture. So if he is off grid, he doesn't have access to electricity, he will go buy solar panels for pumping water because that helps him de-risk his agriculture. So the conversation is not about whether the waterways are getting polluted, but how can he earn a dignified livelihood by embracing this green transition. And there's a new term that has been coined in recent years as a just transition. It's not just embracing green, but also doing it in a just manner, such that the people at the bottom of the pyramid, the people who are living in sub-Saharan Africa and South Asia, 85% of the farmers are smallholder farmers. They don't have access to capital. They don't have access to internet. They don't have access to microcredit. For them to embrace green transition comes at a very steep price, and they would be inclined to take that only if it also comes with a just transition. You can create green jobs for them, you can educate them, you can increase their income potential, you can give them microcredit such that they're able to embrace that. So that's the parallels I was trying to draw was, okay, mining has led to some benefits for some parts of the society, but it has left a lasting legacy which we are still dealing with. But same thing is happening in the field of agriculture. There are winners and there are losers. Africa produces a lot of cocoa, coffee for the rest of the world, but it doesn't consume that because it's just stuck in that cycle of having to produce cash crops to be able to sell that cash crop, to be able to earn the euros and dollars to pay back the loans that they have been accumulating since the time they were colonized. So it's a long story, and there is history, there's geography, there is sciences, but the world is the way it is because of the historic things that have happened in the past, and we are living with them. So it's very difficult to start on a clean slate. Yeah, thank you.
And there's a statistic, isn't there, about how much water is required to grow the coffee beans?
So I'll preempt my tomorrow's lecture, and I'll just tell you, each one of us, according to the USDA standards or WHO standards, needs about 2,500 calories a day. And on average, based on what you eat, whether it's rice or bread or meat or coffee or whatever you have, each one of us needs about 1 liter of water to produce 1 calorie of food. So each one of us here is consuming 2,500 liters of water. Just a cup of coffee you may have had outside takes 190 liters of water. Just the coffee bean and production of coffee, it takes 190 liters of water to produce a cup of coffee. So there's a huge water footprint in agriculture. Almost 85-90% of all the fresh water is going into food production at present. So all other sectors combined are adding up to less than 15%. So agriculture is a big consumer of water and abuser of water.
Excuse me. So that's quite a scary statistic, really. No more coffee. You mentioned solar powered desalination. I know that to use green energy in that way ends up increasing the salinity of the ocean. Isn't that correct? So we're talking about short-term solutions for problems
Right.
versus the long-term.
That's the thing, like you may solve one farmer's problem, but if you look at the river basin scale, if you look at the larger scheme of things, there are winners and losers. People upstream may be better off than the people downstream, or you may be having plantations on ground to have strawberries during Christmas time inside greenhouses using desalinated water or something, but at the same time you're polluting the oceans by increasing the salinity levels. So all kinds of everything, all comes at a cost. It's just that what cost are you willing to pay, and some of it requires behavior change also. It's need versus greed. In fact, it's the diets that we want. Like if you really want fresh tomatoes for Christmas to make your salsa, it is coming at a huge price to the environment. The greenhouses that are producing that is far away and then being shipped to your doorstep. The environmental footprint of the kind of lifestyle that we live at present, especially the people who are willing to shell out big sums of money, and you want to have exotic fruits and vegetables and cheese and meat and stuff, it comes at a huge environmental cost that our children and grandchildren will have to pay. We are consuming it all and not leaving anything for the next generation the way we are going. In fact, the business as usual case, the way at which we are exploiting natural resource base, we require about 2.3 Earths to continue business as usual. It's alarming. If you've been reading about the planetary boundaries research that is done by the Stockholm Environment Institute, there are 15 planetary boundaries within which we have to live, and we have already breached 9 of them. In terms of acidification of atmosphere and oceans and other kinds of contaminations, we have already breached 9 out of 15 of those planetary boundaries. So business as usual is not the way forward.
We were talking about, between ourselves earlier about concerns about green energy being the only way forward for the agricultural sector. But aren't there some lessons we can learn from the past that would help in that respect?
Yeah, in the sense like we have had in recent times biofuels as a revolution, saying that you can get away from fossil fuels by growing biofuels. But then there was starting to be a competition between, do you use your land and water resources to produce a food to feed yourselves, or you want to produce biofuels with the limited land and water resources? So there's always a competition, and it's just that the winners are sitting in the OECDs, the developed countries, whereas the price is being borne by sub-Saharan African countries and elsewhere that are trying to jump onto these revolutions and trying to mine things or produce things, and at a huge environmental cost, and people are malnourished, people are dying, and people who are producing meat are not able to consume that meat. People who are producing coffee are not drinking that coffee, and it's just that it's a very unjust world. Yeah.
Would you be advocating the use of more indigenous crops and traditional methods?
So I was looking at the example of Egypt, because you have this Nile, Resilient Nile project. So Nile River and Egypt is where agriculture originated. The domestication of crops started. They introduced to the world, how do you grow wheat? How do you produce bread? How do you do irrigation? How do you lift that water from the river and use it for agriculture? But also, the world already had indigenous crops that were meant to survive very harsh climatic conditions, high temperatures, high salinity levels, could grow with very little water. And over a period of time, we have gotten away from those. Almost 60% of all the calories that we get are from 6 different crops. It's maize, it's wheat, it's rice, and a few others. And we have forgotten everything else that our forefathers were eating. Beans, lentils, chickpeas. There's so many things that nature used to give, which were requiring very little land and water, could grow in 50, 60, 70 days. And if you were consuming, they were really good protein sources. And now we have moved away from those to more animal-based diets, exotic diets, and more carbs coming from maize, wheat, and other kinds of crops. So indigenous crops is a way forward to go back in time, learn from the past, and see if you can bring, like acai berry was happening a few years back. People wanted to consume those. All kinds of stuff is happening. Quinoa was an indigenous crop that people had forgotten, and now it's coming back. There's so many others, but behavior change, diet change, and learning from the past and going back in time and trying to see if there is something in the past that has natural resistance, that is naturally meant for human consumption, for giving you lots of calories. It's a good idea to learn from the past and bring it back. Even in organic agriculture, people are realizing organic was the right way to go, and they're going back in time and trying to see if you can have manure and biochar and other ways, biological nitrogen fixation using lentils and chickpeas and beans, if you can have crop rotation to improve your soil health. There is so much that people are doing today where you can find parallels in the history.
Organic fertilizers, for example.
Organic fertilizers, biochar, compost, all these things are coming back, and people are trying to reduce the environmental footprint of food production by trying to be more humane and be less intensive in your agriculture. And it's like land sharing versus land sparing. Do you really want to intensify agriculture in a small portion of land, or do you want to do in an agroecological way everywhere, such that you can coexist with nature and yet be consuming those natural resources for producing your food and to feed the animals? So there is a way forward. There is a balanced approach possible. It's just a greed versus need, like to what extent you want to maximize your profits, your top line, your bottom line, versus trying to just do enough such that you're leaving something for the next generation. Yeah.
Maybe now would be a good time to introduce our next panelist, Dr. Joe McConnell, if you wouldn't mind. Joe is a snow hydrologist, a glaciologist, a climate scientist, and a paleoclimatologist. He wears many hats. Now, while I'm sure that you take Dr. Nangia's point about traditional practices, I'm sure that you would not want to see the green transition abbreviated or halted.
Yeah, so just a little background. I'm a, can you hear us all right? No, turn the switch down. There we go. Just a little background. So I'm an ice core. My focus is on ice core science and ice core chemistry. And so I've developed arrays of ice core records from the Arctic, the Antarctic, and then a few alpine regions in the lower and mid latitudes. And as it turns out, about 25 years ago, I started focusing on lead in ice cores. And originally, my focus was originally on the last 250 years, the kind of time frame that you're talking about. I'll say even more extremely, the last 150 years of the Industrial Revolution. And then about a decade ago, ancient historians and archaeologists from Oxford contacted me and said, I guess they'd heard what we could do with ice core and lead records in these remote regions, and asked me if we could develop similar records for the Roman period. So 2,000, 2,500 years ago, something like that. And so we did, and working with these guys, we did. And so we can reconstruct atmospheric lead pollution year by year, actually subannually, going back 3,000 years. Now, Mark was talking about mostly he was talking about his term for distal is, on the order of 60 or 100 kilometers downstream from these places. My definition of distal is 4,000 or 5,000 kilometers away. So imagine that in the Roman period, we can very clearly see it. In the Roman period, we can see year by year variations in lead pollution in the Arctic and in not Romans in the Antarctic, but we can certainly see Potosi in the 16th century, the beginning of Andean large-scale European supervised mining in that part of the world. And then, so originally we were starting out looking at human impacts on the environment, and then that was reversed into looking at, could we understand something about humans by looking at their impacts? And then finally, the question is, well, what were the impacts on those human civilizations? And so that gets into epidemiology and trying to understand what were the impacts on Roman civilizations from their lead pollution.
The detrimental side effects of mining and metallurgy have been with us a long time in that case.
Yeah, so we can, earlier this year, we published a paper where actually one of the co-authors was a graduate student at the Yale School of Public Health. And in that, we used our lead records from this array in Greenland of ice core records and atmospheric modeling, pretty sophisticated atmospheric modeling, to figure out how much pollution, what were the atmospheric emissions required from Europe in order to generate the pollution that we see in the Arctic. That gives us a number. This is during the Pax Romana, so let's say 15 BCE to 165 CE, something like that. And so this is the empire. Then we take that emission level and we use similar atmospheric models to spread that pollution, that air pollution around the Earth, around Europe, basically around the empire. And then we can use modern epidemiological relationships, hence the School of Public Health, to link those atmospheric lead levels to childhood blood lead levels. And then again, using modern epidemiology, connect blood lead levels in children to IQ decline. And what we found was quite surprising, a population-wide 2.5 to 3 point decline in IQ during the Roman Empire as a result of their metallurgy. Mark was focusing on lead mines. It turns out the reason that we can reconstruct the economy of the Roman economy, for instance, or medieval economies, the reason we can do that is because the linkage is that silver, which ran those economies, that's what they made their coins from and so forth. The silver occurs as galena, primarily as galena ore. And galena has about 10,000 times more lead than it does silver. So imagine for every ounce of silver you produce 10,000 ounces of lead. So the other nice thing about lead is it has very low background levels in the environment. It's pretty clean, and the natural environment is pretty clean with respect to lead. But humans produce a lot of lead, and so it's a really distinctive marker.
And that's the smelting process.
Mining and smelting, yeah. The mining, of course, you can imagine mining is on dust. It's typically linked to dust particles, and they don't travel very far. But the smelting operation produces gas phase lead emissions, which can transport much further just because they're so much smaller.
And how significant a problem were pollutants then compared to now?
Yeah. So Mark stole my line about the hair loss, but anyway, just when I was a kid, when I was growing up, lead was everywhere, right? I could remember distinctly as a kid seeing painting our house in New Mexico and going to the store to buy the paint with my dad when I was maybe, 10 years old. And there across the bottom of the paint can was, bright white with lead. And lead was a big, it's like, it's the really good stuff, has lead in it. And then in the early 1970s, the Clean Air Act was passed in the US and implemented in 1972. And that started the phase out of leaded gasoline in the US. It was about 10 or 15 years later in the UK. At that time, young people may not recognize this, but at that time, you went to the gas station, you didn't fill up your own tank. Somebody else came out and filled it up for you. And I was one of those people who came out and filled up your tank for you. And I used to just come home just drenched in oil. Gas. It was just crazy. To the point, and so I'd really like to know what my lead levels are now. Anyway, so at that time, the U.S. average blood lead level in children, 0 to 5, was around 15 between 1976 and 1980. And they, for some reason, use this funny micrograms per deciliter. I don't know why they use deciliter, but anyway, micrograms per deciliter. During the Roman period, we think it was around, based on our stuff, the elevation from the atmospheric air pollution was around 3.5 to 4. Children from 2015 to 2020 in the US had a level of 0.8. So the Romans were exposed to about 4 times what people are today, children are today. And that's dramatically less, though, than what we were exposed, those of us sitting up here were exposed to when we were young people.
Some of you might be wondering why a historian is being asked to moderate this discussion. And that's because one of the principal aims of our study group is to try and learn lessons from the past and apply them to the future. And so the key is to find a balance in the research between the humanities and the sciences. And one of the interdisciplinary groups that is doing this really effectively is the Yale Nile Initiative here at Yale. And I would like to invite the principal investigator of that project to the stage, Joe Manning. Also a gentleman who wears many hats. He's a professor of history, professor of classics, and of the School of the Environment here at Yale. So for those of the audience not familiar with the Yale Nile Initiative, would you like to explain something about our project and its aims and work?
Thanks for moderating. And I promise we're going to open up the questions from you guys in conversation a little bit in a couple of minutes, because I think it'll be productive. So the Yale Nile Initiative has been going on now for roughly 8 years with NSF funding, when NSF was funding interesting historical projects. May it continue in the future at some point. And what we've tried to do is combine paleoclimate proxy records, ice core geochemistry around volcanic eruptions and volcanic forcing of the East African monsoon, which is the source of the Nile flood every year. We've established those links, I think, pretty well with climate modeling and proxy records. And because Egypt is so good with written historical sources and archaeology as well, we can start integrating historical records and societal responses to flood suppression that we can see on annual and decadal scales, basically, which is a fairly new kind of thing to be working on. So it's really exciting. We have a more dynamic view of an ancient society. We work on the Ptolemaic period in particular because it's a nice place to focus. That's my specialty, which is sort of nice, but it's also as far back as we can go with a density of historical records to understand the connection between human response and these short-term climate changes caused by volcanic forcing of the East African monsoon.
And so what lessons can history tell us
Oh,
about
Lord.
what happens to river-dependent societies when there is a kind of an extreme climatic event like a volcanic eruption or a flood?
Well, we've learned a lot with a lot to go on annual and even decadal responses from the point of view of what a state does in the fiscal system and its institutions to farmers on the ground, because we have sometimes some really nice records. One of the things about the Ptolemies that's interesting, I think, is we tend to think it's capitalism in the last 500 years, which has really changed the world and has really caused these inequalities north-south and otherwise. And it's true to a large extent, but it goes further back than a capitalist economic system. The Ptolemies, when they come into Egypt, introduce free threshing wheat, a new kind of wheat, a bread wheat that the Greeks preferred. The Egyptians grew emmer and barley. The Ptolemies switched the crops pretty extensively, and this new wheat crop is more sensitive to drought. It's more water sensitive, and that probably introduced a lot of risk into the countryside, which we're just beginning to understand. And we can start from our land surveys that we have in this period. We can see farmers trying to switch crops at a very local level, throwing mixed seeds into land because the wheat is not doing particularly well, and it fails naturally more regularly as well. So that's some kind of lesson there about that states can actually alter a natural equilibrium that was thousands of years before the Ptolemies come in Egypt and run it. And you can start seeing the impact. They need it for Alexandria, but they're also selling this new wheat into Mediterranean markets, which is a really important part of what Kings are doing. But it's not great for the countryside as far as we can see, with more to go on that.
And very
One case
similar
study.
to what you were saying yourself. Yeah. Okay, well, I think what we should do probably is have some questions. Who would like to ask one of the panelists something? Allegra.
I have a lot of questions, but in the vein of like, how can history inform what we're doing now? The most striking analog, as we could assemble this particular panel, to me, we've talked a lot about the lead contamination, is our current like plastics contamination. It seems like there is a lot of analog, like we didn't really know it was bad, put it in everything, all of a sudden, hard to measure. So what lessons can we learn from dealing with lead in our current plastic hole that we've dug ourselves into?
Mark,
There we go. It depends very much of what contaminant we're talking about. So in terms of the emerging contaminants which were raised compared to, let's say, plastics, compared to lead, these are, in terms of their chemistry, in terms of bioavailability, in terms of their preservation, in terms of the longevity, they're very different. If we just focus on the lead story in terms of contamination, the lessons that we can learn directly from that is not to repeat unregulated discharge of contaminants into the environment. And I should have pointed out that actually the figures that I'm giving are probably, I won't say an order of magnitude underestimate, but they are a significant underestimate. Also, in terms of learning from the past, that these contaminants get reworked. So there is a climate story there, because up until probably 20 or 30 years ago, the scale of remobilization, these are all sediment associated. I say, water cleans it up pretty quickly. If you stop putting the rubbish in, within reason, it cleans up. Whereas in terms of these sediment-associated contaminants, and some of the emerging contaminants are in that ilk as well, but they do actually decay. They do disappear eventually. Even some of the major pesticides, there is not a half-life, there's a radioactive, but there is a life. Climate change remobilizes these contaminants through increased flooding, bank erosion, and so on. And because that then cascades in terms of agricultural systems, that then increases our exposure. So I think the lesson from the past that I would suggest in terms of the mining industry is to know where the contaminants ended up. And we have that technology, we have that mapping tools, and not to repeat the problems of the past. But I'm not going to get the phrase right, but history never repeats itself, really, does it? And there are inflection points. So in a sense, the riverscape, I'm a fluvial geomorphologist, the riverscapes we're looking at now are not the same in the Nile as they were 2,500 years ago. They're not the same as they were 100 years ago in Victoria. So we've got to be mindful in terms of, although it can inform, very often it can't be used in an unthinking way in terms of contemporary management. So we are at a particular moment in time, particular population. So my expertise is in climate change impacts. In terms of what, for example, the jet stream is doing at the moment in terms of polar amplification. We are in genuinely uncharted territory. So, yeah.
Well, nothing is going to be a blanket solution for all locations.
No, I think it's going to be it's got to be evidence based. I mean, I'm not of the Michael Gove expert sort of thing of the past. There is a but the serious point is that I'm talking about my politicians, not your politicians. The politicians and regulators have actually got to listen in a thoughtful way to what we are telling them to do in a nice way. And that is the biggest problem in terms of actually getting some joined up thinking is there is a systematic disconnect in terms of many of the policymakers, many of the politicians, and many of the regulators. So it's a real problem in terms of those issues. Anyway, my polemic would go on.
In terms of distance, sorry, go ahead.
Okay, thank you. So I'd like to ask this question as a historian, not a scientist, but this is about the tailings dams. And I was wondering if you could just explain, over the last 100 years, how exactly these are constructed, what is it technically that they consist of, and how have they, how have they changed over the last century? And what exactly constitutes failing? Like, I know they leak or whatever, but, what is it that ceases to function? And then you said that you had looked at these around the world, but I'm just wondering, when you look in a kind of tropical or semi-tropical area, how you see both the construction of those and the failure. And if you could just compare these maybe to the kind of pits or landfills that have been used by petrochemical companies in similar districts.
That's a brilliant question, and I'll send you the paper we just published in Nature, which actually, which touches on all of those issues. Just quickly, yes, there is a history to these things. And some of the earliest tailing dams were actually constructed in Australia. Pretty well, actually. Yeah, well, no, there was so much rubbish going, the rivers were overwhelmed. There are different styles of engineering, whether you are in a mountainous environment like the Andes, for example, compared to if you're one of the examples I showed you was in the Hungarian plain. So it depends on the physiographic conditions, and also in terms of whether you're in a major earthquake zone. There is pretty systematic data going back to probably just after the Second World War. There is massive underreporting in China and Russia. And that's problematic, obviously, in terms of doing sort of global modeling. There has been, as a consequence, there's a new tailings dam commission, which was set up after the big failures, very belatedly, in Brazil. And there is a whole series of design guidelines which are being introduced. Unfortunately, they don't go far enough. And unfortunately, the notion that we've got climatic instability hasn't really been factored into them. This has been dominated. Most of my mates are engineers, but I'm allowed to be cruel to them. They still haven't quite got, I might get attacked here, sort of climate change and changing storms and non-stationarity it hasn't really quite got there. So they're still designing these things, assuming that things are not going to change. Yep. What they did in the 1950s very often is they used the tailings themselves to actually in places like Romania and part of the Andes. They actually used the tailings itself to create dams, right? So basically, there was very often no hard engineering. The hard engineering actually only emerged in the 1970s. So basically, and in places like we work in Zambia as well, and you saw that the sludge ponds in Ballarat in Victoria, these were very poorly constructed. And they were only constructed because some of the various early pollution commissions were both in Australia and the UK, the earliest. And there was a move to stop the waste getting into the rivers, and also in the US in terms of hydraulic mining. So these were designed initially to basically block these valleys to stop the rubbish getting downstream. And then there was a degree of sophistication which continues. But these tailings dams have got bigger and bigger and bigger. And we worked on the Mount Poli failure in 2014, which was actually the largest one then today. The ones in Brazil were slightly larger, but those weren't contaminant metals. They were actually, it was iron. It was overwhelmed the system. But yeah, I can, if you give me your email, I'll send the review to you. But thank you for the question.
We have a question there.
My name is Aaron. I'm a second year in the School of the Environment, and it's really incredible to have, you know, all of your different expertises on this panel and to get this integrated view. My question is kind of about narrative control and maybe invoking, you know, sort of the court of public opinion. As you said, you know, there's some of the folks who might prefer sort of the status quo of doing things might have more access to, you know, the folks who have influence to control narratives or put them out there. So I guess my question is, you know, this is the broad question, then there will be a more specific one. So the broad question is, how do we as academics and practitioners engage the court of public opinion? How do we apply, you know, public pressure? That's the sort of broad and possible question. The more narrow specific question that I'm curious about is, do you have any analogies that help to show people the gravity and mechanism of the contamination in the industry? And, you know, like analogies that sort of draw people into the nuance rather than saying like, oh, this is this impossible thing, and just kind of saying, I'd rather not deal with it.
I'll have a go again very quickly. We've just started a whole series of crowd science initiatives in Mid Wales, working with local people and using XRF guns, so basically a mobile technology. It's an XRF, it's like a star, something like a Star Trek, but costs about 30,000 quid. And you can actually go into these mining impacts environments. You can do rapid evaluation. And again, I'm plugging it, I think, for the third time. If you listen to the podcast, it actually describes one of these interventions. I mean, the way I'm sort of portrayed it, like I'm sort of some saint, which clearly I am not. But the serious point is working with local communities, talking to them in terms of where they get, and this applies not just in the UK, this applies globally as well. I've worked in Bolivia for many years in terms of working with indigenous folks there as well. And also in Central Asia. Explaining to them, not patronizing them, in terms of what it means, what these concentrations means, how they can prevent it getting into their foodstuffs, so what they grow. Don't grow mushrooms, carrots, radishes, for example, because that's where it gets into. Build raised beds, get your soil in, get it tested, and actually work with folks like us that will provide them with maps and guidance. And I think, just to end on this thought, I mentioned in 2000, when we first alerted in the UK that this was a public health concern. We had huge pushback from the politicians on this, massive pushback. Now, the world has turned upside down. So our local MPs, highest government level, they want to know where these contaminants are. So there is a mindset change. But I suppose the biggest challenge, and this is a question again I'm always asked, is what values are significant? How much lead in these soils is going to affect our kids' IQ? Is it safe for me to fish, etc.? And again, that all needs to be nuanced. And there's a lot of place understanding that you need to bring in. I'm not a clinician, but I do work with ecotoxicologists, and they're learning from us and we're learning from them as well. So yeah, work with people affected. Don't scare them, but indicate to them small changes that can make a huge difference in terms of their risk. And that applies anywhere on the planet. Pleasure.
Thank you all. My name is Alex. I'm the Director of Research and Impact for Planetary Solutions. Really excited to hear all of this and hope the workshop goes really well. This may not be the expertise of any of you, but recognizing the long historical legacy of pollutant once it gets into a waterway or soil, recognizing the large order of magnitude of the lead to silver, or the pollutant to the desired material. And I wonder if anyone could speak to policy or kind of the science around preventing the creation of new mines specifically via like recycling. The idea of how much material is there of copper going around, or how much silver is there, and we hear like we should mine our dumps, or like you can pick up the stuff from the catalytic converters or the gasoline that fell on the road and get appreciable amounts of minerals out of it. Just curious, kind of your sense of the scale and kind of what exists today in terms of efforts to find these materials in ways other than mining.
Could I just add to that as a CODA? First of all, thank you for your support the next couple of days. I was going to, since Alaska is my happy place, and I know places like the Salmon River, which was this beautiful, pristine river, which is now running orange, and it's not the only river. Yes, there's going to be more mining, at least proposed in Alaska, but there's also the problem of permafrost melting into the rivers too, which contain a deeper historical memory of pollutants. And I wonder how that would add to this, or make it more complicated, this overall question of pollutants in river systems. How widespread is that, for example, outside of Alaska and the Russian Arctic or something?
I mean, to answer your question in terms of recycling, yeah, I mean, Karen Hudson-Edwards, who is one of my co-authors, is one of my first PhD students, who now head of the Campbell School Mines in the UK, and she is a sort of world expert on the circular economy. But I wish I could be more sort of optimistic. She is now not convinced in terms of the economics of this. And again, in terms of, potentially, for example, in terms of places like Romania, under Ceausescu, there was incredible wasteful mining industry, and it would be possible to revisit it. But in terms of, there's a big court case at the moment called Rossa Montana in Romania, which is the largest gold mine in Europe. Rather than actually reprocess these tailings dams, and they need cleaning up, they're incredibly contaminated, and they're not going to rewild. The mining company have decided actually to reopen a much larger mine and not to reprocess this material. So again, it's as we were saying, people make an economic judgment. It's not good news. We worked a lot in Kosovo as well, where these tailings ponds, big problem in terms of dust. Big problems in terms of Roma people getting poisoned We've worked with the British government on that. So no, I'm not full of joy, and I'm actually a genuinely optimistic sort of individual. But I think what I said earlier on, each of these needs to be looked at a case-by-case basis. And I think if there was more incentives to do these things, but that's very difficult in terms of people that are making decisions from a purely financial perspective. I think they will get to a point where we will have to, as you were suggesting, we're going to have to look at this at a planetary scale. But I just hope we can make that decision sooner than later.
Thank you. And just to follow up and to try to temper the despair. I'm just curious, is there an example anywhere in the world of any scale of government that has tried to price in the negative health or negative loss of agricultural productivity or negative anything into decision making around mine production, like mine leasing or other things, in a way that has had some effect?
There is, and this is again not special pleading. I'm not Welsh, but I'm actually Anglo-Irish, by the way. The Welsh government has the Future Generations Bill, which is unique in the world. And they are specifically, and obviously Wales, as I've showed ad nauseum, has got a mining problem, that in terms of decision making, that in terms of future generations, that this will have to be considered. So, yeah, but there needs to be a lot more of this. But as was suggested, it's people's livelihoods, and it's not for me. You know, my ancestors in Northern Ireland, 150 years ago, were scraping a living before they went to Bermondsey in South London. But yes, there is thinking along those lines, and we need to have more of it.
If I may add, I think people don't react unless they are directly affected. Each one of us wants a new iPhone each year. We want a nice new car. But where does the old iPhone or the old car go? We don't want to know. We want it at the cheapest possible price point, but we don't know the environmental cost of that commodity that we are consuming. And politicians in the private sector, they want the economy to keep running on steroids. They really want us to keep consuming, for them to keep getting your votes, keep maximizing their profits. And nobody's thinking long term. If you look at the green revolution that happened, that helped feed the world, it came at a huge environmental cost. All this fertilizers that we produce, urea that we applied, these varieties of plants that we developed, the irrigation dams that we built. Now we are realizing the arsenic in the groundwater, the chemicals that are around, the salinity that has been built up, all these environmental consequences of that green revolution. Now we are realizing, and we are studying, and we are trying to get things right. We are trying to have better dams, better fertilizers, better plants. We are learning from history, but only when there was realization that the people living there are starting to bear the cost. As long as your iPhone is made in China or elsewhere, I think we are all in a denial, saying that it's green iPhone, right? But there are people in Africa mining those metals to make those phones, those chips, those shipments. So there's this science that is the valuation of ecosystem services, what nature gives you, and what's the price of that commodity that you get from nature, whether it's clean air, clean water, forest, snow. If you actually start putting a dollar amount to nature, that's the true value of the commodities that we produce and that we consume. And actual cost is in trillions and trillions of dollars, not what we pay. Yeah.
I think we can take one or two more questions.
Was there somebody else?
I have a question. Is it?
Well, it's
Oh, here, let's get a new voice. Thank you.
Yeah. Hello, my name is Pablo, first year MEM from Chile. So a lot of mining, and copper is within my horizon, my country's horizon. I have one question, because we have been talking about how to fix the tailing problem or the water pollution, river pollution problem, and the challenges that have been like from the economic perspective. So, the economic solution, market solution, we know that's maybe not the way to go right now. Also, we have been talking about, like, from the policy perspective, it's still been like difficult to go into that direction. So looking forward to the amount of mining on the ground of mine they will have, the time that we have, what do you think is the way to go? Is policy, is the market, is public opinion, is it's a combination of those? I don't know, like, that's my question.
I think it's
How
the
do we
age-old
advance?
story that the public have to drive the agenda. They have to say what their priority is.
Yeah.
And the only way to do that is by mobilizing and by voting and by banding together. And it's and for society to decide where its priorities are, because the rare earth minerals aren't just useful for green energy, they're also used for aviation, and they're used for weapons, and they're used for manufacturing all kinds of things, and we really need to decide where the emphasis is going.
I just want to put one more point of it, because I agree that it's, among the public and the public opinion, maybe this, like, we couldn't hope that is the leverage that we need to pull. But it's also, like you said, like just right now, it's like, it's also a very difficult leverage to pull, like from one day to another, because we're still debating over our consumption patterns, and public opinion among the whole world is also difficult. So yeah, that's my question. Like, I know the public maybe is our best option, but it's also like the most diffuse option.
Unless you organize, but go ahead.
I just wanted to say there's a huge disconnect between academia and the science that is being produced versus it reaching the common man. The messaging, the complexity with which we speak versus their ability to those punchlines, those key take-home messages that have to stick with the common man. There's enough science around us. It's not like we have to produce new science. In spite that, it's not being taken up because of the price point. At the same time, ignorance in the society about the environmental consequences of our actions, what has happened, what is happening, what's going to happen, where the trends showing. Everybody is just living election cycle, like every 4 or 5 years there is election coming, and that's all that people are aiming for. They don't have a long-term horizon of thinking where are we heading. And I think what happens in academia and the way we talk and the way we convey message versus the common man's ability to understand that, there's a huge disconnect. So there's a communication gap there as well.
I disagree.
If
That probably does as well.
Yeah, I mean,
because his
just
work is really focused on
I think
making the story, finding the stories,
Exactly.
to communicate the issues.
Yeah, I think people on the ground, I mean, probably like yourself, I mean, I've worked all over the world. And actually, when you're working with people that are affected, I was in Chile very recently, and I've worked literally all over the world. And these have been with local communities. As a typical Englishman, I don't speak any foreign language, so there's always a linguistic problem. But just in terms of explaining to people, working with them, they are fully aware of what the issues are. But there is obviously a tension in terms of making a livelihood or not. And I always remember working in Bolivia after the big Porco spill in '96. And there were major irrigation systems that were affected in the Pilcomayo. And there was incredible sort of patronizing approach by a lot of the NGOs that sort of were working in those areas. And we came along and worked with them for many years, saw how they dealt with it. And actually, they managed the contamination issue in a very informed way. And I've seen that repeated time and time again. I think the issue that we have in terms, I mean, academia is about good academics should be good communicators. So the only thing that I ever get really irate about is when someone calls me on occasion an ivory tower academic. And I say, well, hold on, perhaps I'm not explaining it to you carefully. But say, I think on occasions there is issue in terms of I'm not contradicting, but I do think if it's done carefully, if it's done on the ground, if it's done from a process perspective, not in terms of imposition from above, then you can actually make a difference, a very significant difference, actually. So sorry to contradict.
Do we need to finish?
I think, yeah, that's a lovely note
Yeah.
to wrap it up on, I think.
So, we'd just like to thank Mark particularly for his really interesting keynote and an important keynote, I think, and our panelists. And I wish we'd had a little bit more time to delve into things, but thank you all very much.
Thank you.